Hello all and welcome to this video where we look at solving polynomial equations. So we're going to do a quick review of solving quadratics, and then we're going to move on to and using some of the tools we've looked at to now solve cubic polynomials. Okay. So as it says in the exercises leading up to this, we've learned how to factorize quadratics applying the null factor law, long division polynomials, and the factor theorem. So in this exercise, we're going to pull all those tools together and use them to solve polynomials of various degrees, mainly second and third degree. So let's have a quick refresh. This should be a bit of warm up. Hopefully you should know how to do all of this, and that certainly needs practice. Is solving a whole bunch of these quadratics. So pretty much all of these, apart from D, we can solve just via inspection. 0, so we're looking for two numbers that multiply to give us a 4 and add to give -5, and that is -1 and -4. And then using the null factor law, and actually I'm going to do a quick refresh on the null. What does the null factor law say? Pretty much the null factor law says if we have any factors multiplied together, or any two things, or A and B, if we have them multiplied together and the answer is 0, it means logic follows that either A needs to be equal to 0 or B needs to be equal to 0. Both don't need to be equal to 0, but one or the other has to. Okay? Another way we could think of that is if we have a box times by a triangle equals 0, one of these two things, okay, the box needs to be equal to 0 or triangle. Okay, and that's what we have in this situation over here. We have x minus 1, one factor, minus 4 is another factor, then multiplied together equals 0. So using this null factor law, we can say minus 1 is equal to 0 or x minus 4 is equal to 0. Both can't occur at the same time as well. Okay. From that, we get x equals -1, or, and I just use 4, x equals. So that's a quick refresh on factorizing, inspection, and using the null. So we're going to use that through 0, multiply to give 45, add to give 14. This one 5 9 16. Okay, therefore we have x 0 or x plus 5 is equal to 0. Therefore we have x or x. So 4 and 4, that's easy, it's plus. Okay, therefore we get x plus 2 equals 0 or 2 equals 0. I'm not going to. Okay. This is a repeated root, a repeated factor, so therefore x is 1 because both of the factors are identical. Now, x squared plus x plus 11 equals 0. Factors of 11 is just 1 and 11. There's no way you can turn that into a 1. So let's do a quick little check. Using our quadratic formula, we know the discriminant is equal to c. So a, b, c. So we can substitute those in. So we get the discriminant is 11 equal to 3. Okay. The discriminant is less than 0. It's a negative number. Therefore, this one actually has. Okay. So we should be. This should all be coming back. Factorizing via inspection, thinking about the quadratic formula. Importantly, I've just gone completely blank. The discriminant. If the discriminant is less than 0, then we know it's got no solution. So the discriminant check here is super. So let's extend. We've done heaps of this before. Let's extend. So apply the null factor law to the following to solve for x. Well, as we just talked about, a times a equals 4b. So we get x minus 2 equals 4 is equal to 0, x is equal to 4x. Straightforward. Okay, what about this one? We have x minus 3, but we have x plus 1 squared. Does that change anything? No, it doesn't. X minus 3, we could write this in full expanded form. Okay, equals 0. In this case, it's just a times b times c equals 0. Again, though, because it's all multiplication of factors, a or b or c must equal 0. One of those three terms must equal 0. So we get 3 is equal to 0, x 0. Therefore, x is 3 or x. And then same thing for this last one. X minus 1 is equal to 0. 2 is equal to 4. Therefore, x 1 or x or x is okay. So the null factor law is just as applicable to cubics, factorized cubics, as factorized quadratics. We can actually use the null factor law in any factorization of any polynomial of any order. It doesn't matter if it's polynomial order 2, so if we had an x squared, or polynomial order 15, so if we had an x to the power of 15. If we factorize it, we can. Okay, so let's use, with A through C, we've learned a whole bunch of tools. Let's finally use divide x cubed plus 2x squared minus x minus 2 by one of its factors, x minus 1. So we're given one of the factors and write in the form p of x equals d of x times by q of x. Okay, so our original polynomial is this. We're dividing by the divisor, this. Okay, so we're going to p of x, we're going to divide by d of x. Okay, and we'd get, if we do that, okay, the quotient solution. Okay, so the question is asking us to divide. So really quickly, if it says divide, that implies use long division. It says factorize or find the factors, then you can use any method, but since it says divide, we're going to use long division in this case. And saying divide a polynomial by d of x. So what we're trying to do is p of x divide by d of x, and we'll find, importantly, our quotient. Okay, and then once we found our quotient, we can write it in this form over here. That's what this question is. So let's do our question. So 1 x cubed plus 2 minus x 2. Okay, so I'm going to roll through this pretty quickly. I can't remember how to do this. Go back and look at some of the other videos and the videos I in Edmodo. Really quickly, we're doing, this is the key term. The minus 1, we've used a little bit through this, but we're always doing whatever's in the polynomial divide by the first, so the x. Okay, so x cubed divided by x gives squared. That multiplication. Okay, that multiplication to give a new line. X squared times x is cubed, and x squared times. And now we're going to subtract this new line from original polynomial, so we get 0, subtract a negative x squared plus 3 squared. Okay, and now we're going to repeat the whole process using this the whole new line here. So 3x squared divided by the x give me x. times by this term again, so we're repeating the process. 3x times x is squared, 3x times x. Do the subtraction, 3x squared 0, which is what we want. Negative x, take away negative 3x, adding 3x, so that's 2x. 2. Okay, and now we do the division again. 2x divided by x is 2. Do the multiplication. 2 times x is x. 2 times 2. Okay, and then we get 2x. Sorry, negative 2. Okay, which is what we want. We want no remainder. No remainder shown up here. So we now have found that's our quotient. We've done our division and that's what's left. So we can now write x cubed plus 2x squared minus x minus 2 equal to x minus 1 x squared plus 3x. And that is written. Okay, written in the form required. Polynomial p of x divisor we divide that we got. Okay, that's what that is showing. Now what we could do, just to show you and preempt the next slide, the question isn't asking for us to do this, okay, but we could fully factorize this. Okay, so we have p of x, what are x minus 1? Okay. This quadratic, we could turn that into x, x. Okay. Multiply to give me 2, add to give me 3. Well, that's nice and easy. Plus 1, plus 2. Okay. We've now fully factorized it. From there, we could actually use, okay, if we were told, not in this case, but if we were told p of x 0, we could then use the, we aren't told this, okay, so we can't use that. That's as far as we could. But to answer, that was taking another step, but that's the solution to add. Right, okay, by first finding a factor, solve the equation x cubed minus 6x squared plus 5x. So we have equal to 0, so straight away we should be thinking the law. Okay, equal to 0, and then because it says finding a factor, how do we find the factor? Well, just like we did in the last video, we get to use the factor theorem. Okay, so to use the factor theorem, to refresh you, we're going to substitute a number in. Okay, we're going to call this p of x. We're going to substitute a number into p of x. Make x equal to 1 or 2 or 3 or 4 or 6 or 12. We're going to choose numbers that are factor at the end. We're going to substitute those in and keep trying until we get p of x is equal. Therefore, that solution works. Create a factor out of that. A bit complex when said, it's much easier when. Let's have a go. So I'm going to let x equal 1. I'm always going to start with nice small numbers. So it follows on. X is equal to minus 6 plus 12. That does. Okay, that's no good. I'm going to try another number. Let x equal, and we can't figure out our negative factors. Okay? We can divide 12 by negative 1. So p of is equal to 1 6 minus 5 all I'm doing is substitute -1 this, and that is equal to 0. Okay, therefore x1 is that works. What can we do from this? Well, we can generate a factor. Rearrange this to get it all equal to 0 on one side, so we get x plus 1, 0, factor. So we now have a factor. We've found a factor using the factor theorem. So what we have now is p of x, 2, x plus 1 multiplied something. Okay, and that's something we started with an x cubed, so that must be x squared plus b plus c. Now, it's asking us to solve, which means factorize or find all solutions. So we could keep going and use the factor theorem, keep trying different numbers. That could work. Or now that we've got this, we could use long division, divide p of x by x plus 1 to find quadratic. Or we can use equating coefficients, which is what I so okay, I'm going to use equating coefficients, which we've done before. So we get x cubed minus 6x squared plus 5x 12 is equal to, and really quickly I'll point out, technically I could put an a in here, or I should put an a, but x squared, this very first term, that's only squared. This x here, that's the only x on this side. These two together, the x times by the x squared, is going to make the only cube. Expand this whole thing, that's going to make the only cube, and since this coefficient, that a is just a 1. Skipped putting that a in there. So we get, and I'm going to, sorry, I'm about to sneeze. Pardon me, sorry about that. Okay, so I'm going to expand this right hand side. I get my x cubed plus squared plus x, that one now, plus x squared plus b plus c, x cubed minus 6 squared plus 12 is, let's group like terms, plus b, collecting the x squared term, b plus 1 squared, that is that. Collect the x terms plus b x plus c on the end. So what can we do? We can equate coefficients. On this side, that's our x squared term. On this side, that's our x squared term. This side, that's our x term. That's our x term. So straight away, we can say nice and easy, c is equal to 12. 5 is c plus b. And also get -6. So c is equal to 12, we could substitute that into this, we get 5 is equal to b 7. We can check that over here, because if we solve this one, we'd get -7. That both. Okay, so we have found our c and our b terms, so we can now write p of x. Substitute these back into this. X plus 1, x squared minus 7x plus So we've got it written in that form, but the question is asking us to solve. So to solve, we need to fully factorize and find all our x values. So this is also equal to x plus x. So what I'm going to do is I'm just going to factorize this quadratic via inspection. Two numbers that add that multiply to give me 12, and two numbers that add to give me 7. Well, so I just factorized that quadratic via inspection. Okay. Now, since p of x is equal to 0, we now get to finally use. Therefore, x plus 1 equals 0, or x minus 3 is equal to 0, or x minus 4 is equal to 0. Therefore, x is equal to 1, or x is equal to 4x. If you substitute any one of those three in to this original equation, it will give you. So a lot of work's gone in there. What have we used? Well, we have used the factor theorem to find our first factor, 1. We've then used equating coefficient to further factorize p of x. Okay. Got the quadratic here. We've then used factorization via inspection to turn the quadratic into a fully factorized polynomial. And we've used the null factor law. So it's 4 main key skills all tied together to find this polynomial. That's it for exercise 6D. If you have any questions, please post them on the Edmodo group page. Thanks.